Hi guys, welcome back to the channel. So today we will start a new problem, that is problem E, Masha and the Garland of the round div 3 that was held yesterday. So what is the problem stating? I will tell you in my words. You can read the problem statement too. So we have given a binary string. Suppose the string is 0 1 0 1 1 1 1 0 1 0 1 0 0 0 1 0 1 0. This is the string suppose we have given, and we have to answer q queries. In each query we have given three things: L, R and K. Basically we have to tell about a subarray whose indices start from L and end to the R. Like if this is L and this is R, we have to tell in at most k operations can we convert this substring, like the alternate elements of this substring, so the adjacent element of this substring would be alternate, like the substring would be 0 1 0 1 0 1 0 1. So can we convert this substring start from L to R in k operations like this? So we have to answer this. So to answer this we can perform k operations. So in each operation what we are allowed to do, basically we can take any subarray or substring from that string, and we can flip the bits or the elements of this subarray. Like if we choose from this array 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and so on. If we choose suppose 4 to 10, then in one operation what we can do, we can flip all the bits from that substring, like 1 to 0 0 0 1 0 1 and 0. So we can do that in one operation, and we have to tell finally can we convert the substring from L to R into alternate adjacent element substring. So that we have to answer. So I think the problem statement would be clear, and first we will go through one example that we have given in the problem statement. So the problem statement example is this. So we have given this string 0 1 0 0 1 1 0. So we have to perform five queries. These are the five queries: 1 2 3 4 5. So if we take first query, so this is a given string 0 1 1 0. This is 1 2 3 4 and 5. We are allowed to perform one operation, and we have to tell can we convert a string starting from 1 to 5 to the alternate string. So can we do that? Yes, we can do that. How? If we flip these two bits, then 0 1 0 1 0 0 1 0 1 0. So the answer would be yes for that. Likewise 1 5 2 also we can do, because in one operation we can achieve this. So in 2 also. So now for 2 4 1, check for 2 4 1. This is 2 4, this is 2 4. In one operation can we do that? Yes, we can do that. How? If we flip this or this, if we flip this, then it would convert 0 1 0. So it is also yes. So this is yes, this is yes, this is yes, and 1 2 0, this is 1. So initially it is not in required state and we are not allowed to perform any operation. The answer would be no for that. Likewise 3 4, it is also not in required state and we are not allowed to perform any operation, so it is also no. Okay, so the answer would be triple yes, double no, and triple yes and double no. So that would be the answer. So I hope the problem would be more clear after the explanation of an example. Now coming to the approach, how can we do that? So let's suppose if we would not think in a way that key, or first go through the constraints. What are the constraints? It is a guaranteed that sum of n and sum of q are 2 into 10 to the power 5. Means sum of queries is also 2 into 10 to the power 5. So that means to answer each query we are allowed to use only log n space, log n time complexity, okay, because in end we have to iterate the queries and the n size is 2 into 10 to the power 5, so only we are allowed to use log n time. So what the log n time is stating to us, either we have to calculate for every query during giving answer, or some pre-computation we have to do like to answer the query. So in these cases most favorably we have to do pre-computation, because in log n very small things we can do. So with log n time complexity, so we have to something do as pre-computation. So this is one observation there. So let us think about how can we pre-compute for every query. Okay, so take the big string. This is the big string that we have. So let's suppose write another big string, and that in that string we will try to understand what we have to do. So this is 1 0 1 0 1 0 1, make it 0 here also, and make some here also 1 0 1, and here 1 1 1 1 0 1 0 1. Okay, so this is a string that we have. So one thing is clear, that every string some alternating bits would be present, like in this string also. Here we can see at that here until in this sequence we have alternating bits, and here we doesn't have alternating bits. Likewise we doesn't have alternating bits here, and here are some alternating bits. So every string consists of should be every string would be always be like that, ki some disturbance is here in some block, and here is the required string, and here is disturbance, here is the required string, likewise. So every string should be like that. Okay, so we have to do something for these blocks. Okay, so first try to think for each block, can we singularly or without disturbing any other element of this string, can we solve this block? First we will do like that, try to think. So in this block basically we have the same strings, same characters, okay, like this or like this, 1 1 1 1 1. Okay, so we are allowed to do, we can choose any subarray, and flip the characters of this subarray. So here if we choose any substring like complete string, or 2 or 3 characters, 2 characters at a time, then it would not create much impact, because if we choose two characters also, then this is 1 1, this is another time we are having same adjacent elements, so we cannot do like that. So what we can do, in one operation, either we can choose this, another operation we can choose this, another operation we can choose this. So here we have even or odd elements, and here is 1, here is 1. Okay, because this is the segment that we have chosen, and this is sorted one, this is sorted one. So here this is always be 1, here always be 1. So if we choose these three and make it 1 1 and 1, then this string would be converted. Okay, likewise, this is what this is 1 2 3 4 5 6 7 size string in which 6 elements are disturbed. Okay, so if even element are disturbed, then we can say that key in size by 2 operations we can definitely make. If we think try to reduce the number of operations, so can we do that? I think we cannot do that if we only treat this block singularly, because this is the only way to make it alternating. If we choose more than one character at a time, then it would not create as much impact, because if we choose 2 2 and in a one operation, then again we have to make this character 0 often, then this 2 would create wrong impact. So we cannot do except this. So, except this we cannot do anything else. So from this we can say that if we have even size substring, basically even odd size substring in which even element are disturbed, then we can do size by 2 operations to make it alternate. Okay, so let's think about odd one. If there is another 0 here, like to make it more clear to all of you guys, we have I am creating another one here. So now this string is like 1 0 2 3 4 5 6 7 8, 3 4 5 6 7 8, and here is a 1. So this is a disturbing element we have, disturbing sequence we have. So here you can see these 7 elements are disturbed. Okay, so we have to make it 1, here we have to make it 1, here we have to make it 1, and now you can see here also we have to make it 1. So if we would make it 1, then it would adjacent to this sequence, and here, as I have told you earlier, here this is our regular sequence. This is our regular sequence, means we doesn't have to change anything in it. But if we do in this way, then it is creating problem here. Okay, so let us think more. So this sequence is something like here 1 0 1 0 1 0 1, or maybe my next disturbing would start from 0 this or 1. Let's suppose it start from 1. So if we want to make it 1, we have to change it. There is no other options we have, because we cannot do anything here to make it alternate. So we have to change this. Okay, so if we have to change this, then is there any impact, any disturbance in these? Can we make it more disturbance here? Answer is no, because already these all have alternates, but the thing would get disturbed this block, because if this block is starting from 1, then here it end with definitely 0. Okay, so if we change this, if we want to make it 0, then we have to change this, and if we change this, then the last bit of our disturbed block would match with the non-disturbed block and create disturbance here also. So here what we can do, make it 0. We will make it this initially 0, so we will make it 1. Likewise it would 0, it would 1, it would 0, it would 1 0 1 0, and this is here 1. Okay, so last element would be 0. Now it would be converted into 1, and this is also 1. So we are increasing one element to our disturbed block. Here, to solve this problem, we are just increasing one element to our disturbed block. So it is problem. We cannot do like that. So now, what another idea that I am seeing here, should I choose this one in one sequence, like this disturbed block and this disturbed block? Okay, and here we have all element that we required. Okay, and this disturbed block, what we can do, we can choose this substring, make it alternate 1 0, make it flipped. Then in this way this is flipped to 0 and this is flipped to 1, and this is 0, this is 1. So in this way also, in one operation we can flip 2 bits. Okay, so in here also we can do like that, ki in one operation we can flipping, when we are make set 2 elements. So in this way also we are make set 2 element, but our problem is solved. Here we are facing issue with the last element when the size is odd, size of disturbed element is odd. Okay, so here we are fixing that issue. If we would go this way, then our problem would solve. So how, next I will telling you how we are planning to do. So these are 8 elements, 4 5 6 7 8, and these are disturb 1 0 1 0 1 0 1, and this is 0 0 3 4 5. Okay, these are only 5 and these are 8. Okay, so here what we can say, we are going in this way, make it 1 0 1 0 1 0 1 0 and 1. Okay, so here you can see these are changed. Now this and this is not same, adjacent are not same here. Okay, so in one operation we can flip 2 element. Like now we would think ki we would choose this next, this to this, but we cannot do that. If we would try to choose this, then our these 2 element would get disturbed, because now see na, this is 1, this is 0. Okay, not these two, not these two, because if we are choosing this sub array, because these two are originally in non equal. Okay, non equal, then we would choose this, then that would create problem here, because these 2 element are same. So we cannot do that, we have to do like that. Okay, so in this fashion we can solve every element in this way. Means third one is with, sorry, this is with this is with this is not there. So here is this and here is this. Okay, so in this way you can see we can use this block to this block. if this block has A element, this block has B element. So if A is less than B, then A element get vanished first and some B element would remain. Okay, so from here, if we for now if we forget about remaining element, then what be our formula? Our formula would be disturbed element. We would calculate what are the disturbed element, count of the disturbed element. So count of the disturbed element is 3 here and 3 here, or we would say 5 here and 5 here, whatever until here. So 5 plus 5 is 10 and 10 by 2 is 5. But if it is odd, like if here 0, here we can see that ki 8 element we have. From 8 elements, 5 we have solved and we are remain with 2 elements. Okay, so G7 plus 5. So now for remaining 2 element, what we can do? Either we would find another group which has more size or less size. So we are just try to find always the another groups, and we in this way and in this way we would remain with only one small group, and all our remaining all our previous group will get vanished into the flip-flops. And what is the formula for that? If we would for now, if we would forget this remaining group, then what are our elements? So what are our disturbed element? If we would calculate this all sum of the disturbed elements like this and this, and sum them, and after sum, if we would do x by 2 or x plus 1 by 2, this would be x plus 1 by 2, not x by 2, because if there are odd elements, then this would cover in this, because if because here you can always find a match. Here you would not anytime get odd elements. If we would get odd, then we have to solve with another group, and last group may have even or odd. Okay, so we have seen this earlier. We would solve this in earlier fashion. What fashion? I have tell you this one, single group, as we are solving. How we solving single group? Like 0, if this we remain with this, if we remain with this, then even element, if we remain with even element, then what we can do? Make it 1 here, make it 1 here. Okay, and in the even moves, in the n by 2 moves, if we remain with n disturbed element, then plus n by 2 disturbed plus n by 2 moves, we can reach to the answer. If we remain with odd element like 0, 0, 0, 0 and 0, okay, 3, 4, 5 and 0. Okay, so if 1, 1 and make it 1 here also. So but this one would never be impacted to another one, another array, because we have solved it earlier. Okay, this would not impact to another one, that problem we are facing here. Okay, so from here we can find that key to solve this group also we required n plus 1 by 2 elements, and here also n by 2. So we can say to get our answer, if we would do n plus 1 by 2, then this would be our final answer for the disturbed element. So what we have to do for any subarray that we want to convert into the required result, then we would try to find what are the disturbed element in this subarray, and whatever be the amount, we would apply n plus 1 by 2 formula here. Then we would get the answer. Now how would we pre-compute? That is very easy. If you are guys are solving this type of problems, then you can easily find that key. Basically we can do prefix sum. Like if we have 0 0 1 1 1 0 0 1 1 0, like here this is 0. If this is matching with this, then we would increase the count by adding the previous one in the current entry. Likewise we are doing this, and at every index we have written how many disturbed element we have until here from starting. And to find in the range L to R, what we can do, we can subtract R to L minus 1. So pre R minus pre L minus 1, and these are our required operations that we have to put for making the required string. If this answer would be less than equal to k, then it would be yes, otherwise no. I think the whole explanation would be clear to all of you guys. Now let's move to the code part. So this is our code. So what I have did, I have taken input n and q, taken string, and here I have make prefix n plus 1 size, and in the prefix I plus 1, what I am doing, prefix I plus, if stri is equals to stri minus 1, then 1 would be added to the prefix I, otherwise 0 would be added. Likewise we have calculated the prefix I plus 1. So now what we can do, we have we have stored answer in the one base indexing. So here from L R K we can do prefix R minus prefix L minus 1 plus 1 by 2. If this value would be less than equal to k, then output is yes, otherwise output is no. So this is all about this question. I think whole explanation and the code part would be clear to all of you guys. So thank you, that's all about this.